the first thing that I would say right now, to make it more presentable, easier to read, easier to deal with, I want you to put the cursor at the beginning of 6 and push backspace so that they all appear on one single line at the beginning. That's it. You do the same with 6, 7, and 8. Or delete, that's a good idea. It's easier. Very good. So now we see a little more, right? So now when we look at 1 plus a over b plus c over f squared, all right? And here, of course, unfortunately, since I don't remember, let me see what the problem looks like. All right, 1 plus a over e plus c over f squared. I think that is perfect the way it is. Does anybody have any problem with that? And when I say perfect, it means there is no need for additional parentheses that could have, you know, could have an effect, meaning that you may decide it's safer, but the more parentheses you use, the worse it gets, right? In terms of trying to read, trying to debug, and everything. So if you have no comments, we can go to the second expression. Now, the second expression, again, there is no need for parentheses for 1 over a, 1 over b, 1 over c, 1 over d, but there is a need for a parenthesis for the whole thing because it's the entire denominator. And if you don't put those parentheses, then it will divide only by the first term, and that's it. So those parentheses are necessary, which is very good. Part C, obviously, again, the same thing. You're dividing the entire numerator by the entire denominator, so the parentheses are necessary. For the last one, it's a times b. Of course, you could always say divide by c directly, or times 1 over c, that's fine. But again, times 1 over c, again, would you need the parentheses? Do you think the parentheses of 1 over c are needed? Anybody? Because if you remove them, then you multiply by 1, you divide by c. That's exactly the same thing as multiply by 1 over c. Okay, so not needed. So let's remove them so that everybody knows what. And of course, in this case, if you wanted to, you could say, why multiply by 1 over c? Just divide by c. I'm not saying you have to, but it's simpler, right? AB times 1 over c, that's 1 over c, that's because of the writing. People wanted to show c in the denominator, but in this case, that's exactly what happens, right? You multiply by b first, then you divide by c, then you multiply by f squared over 2. But in this case, that's not true. MATLAB will deal with the parentheses first. Now, do the parentheses happen to be needed again? And of course, David will say, I guess not, right? Because if you remove them, you divide by 2. That's all right. But the first thing that will happen is f squared. And then you multiply a by b, divide by c, divide by 2, and multiply by f squared, divide by 2. That's exactly how MATLAB goes after the operation, right? So even then, the parentheses should not be needed. So David, that means you can remove them. Do you see what I'm saying now? When you look at the operation, f squared gets to be done first. Then it's a times b divided by c times whatever f squared was equal to divided by 2. That's the order of the operation. So f squared is first, then from left to right, a times b divided by c and so on. And that's exactly the expression that you have. So when you write in MATLAB, write it so that it is correct, but you don't have to follow the way it's worked on a paper, right? On a piece of paper, we have a standard, and in MATLAB, you should use the most efficient way to present the operations. And so parentheses are not a... Yes, go ahead.
I have a quick question. Sorry, I didn't mean to interrupt. Did you record
No, go ahead. I'm recording.
No, I'm talking about the last class. I had a family emergency, so I wasn't able to attend. I was wondering if
Oh,
you
I
could.
always record. I mean, unless I forget maybe a piece of it, or I forgot until the students remind me. But they're always, when you open up the room, I think there is in the menu there is a one portion that says recording.
Okay, I'll check it out after the
Did
class.
you ever
Thank you.
check it out?
Yeah, I'll just check it out after. No worries. Thank you,
No, I'm
though.
saying I was guys. So I assume you didn't do it before. That means you didn't check. So it's all right. But the recorder should be there, hopefully. And I'm sure your friends will tell you if they did, right? If they did check it out. And if you execute this program, do you get the same answers that you did before, David? Just run, not section. No, not section, because, well, obviously, theoretically, obviously you were not aware of this, but in the future, I want one program per problem. You don't put them in the same, yeah, like you did here, right? And the reason is that sometimes we want to see one problem at a time for whatever benefits we get. But second, that a variable in one part may affect another part, right? Another problem. So we want to keep them separate. Now, however, when you submit, if you can put them all in one single file, that would be better, because then I will look at one file and I get all the problems. So you can use insert, copy and paste or whatever, but from a document point of view, not from MATLAB point of view. Oh yeah, so if you can run it that way, that's good. If you want to run section like that and make them separate that way, that's fine with me. But I'm just saying that even then, when you run another section, the variables that you used for a previous problem will still be in the workspace, and they may affect. Of course, that would be in the workspace even if you run them separately, right? But one has to be careful about that. Like one variable could affect another problem. Uh, And of course, I suppose you get the same values that you did before, right? With or without the parentheses. So I will let you decide, or let the students decide. Or if you have any questions, please ask David right now. If we move on, I will not entertain any questions about this problem, because I want the students to work together, and I want to see what the students would answer to a question from another student. Because tomorrow you'll be working with colleagues and you have to interact, right? So you have to learn to talk to each other. Okay, next one. And again, thank you, David, for helping in the process. So in terms of the next one, so we have, again, 4 sections. The first one is, here we could have made them directly, right? That means since they talk about A equal, so in this case we just say A equals straight up. Instead of presenting them as data, right, we perform the straight operation, right? So if you want to, and of course A1 times A2, you'll end up with A and S equal, right? So as line 29, for example, you could say A equal no A straight, no A1, because there'll be A, B, C, D, so we just say A equal, right? A equal, and then straight up, the 3 plus 6i times minus 7 minus 9i. But again, here, of course, we need parentheses, right? Otherwise, it'll be just a portion that multiplies another portion, right? Yeah, times, yes, very good. And negative 7, negative 9i. And that should be it, right? And when we present a digit before I, MATLAB knows it's a complex number, right? We don't have to worry about it. So in this case, we can compare the two numbers. Can you do the same thing with line 34? B equal and again the same thing with the line for C, line 39. Oh, no, I. 3I over 2. Okay. That again, you can do it that way. You can do 3 times I divided by 2, 3 divided by I times I, 3 divided by 2. Now, 3 divided by 2I would not be acceptable. Why? Just put a semicolon there, and not semicolon, a comma, and put the other form. 3 times I divided by 2. No, sorry. What did I say? 3 divided by 2I. Would that be acceptable? And I can assure you it's not. Why? Would anybody be able to say why this would not be acceptable? I'm not asking for correction. I'm asking why is this not acceptable? Why is it not the same? If I put 3 divided by 2 times I, that would be acceptable. But 3 divided by 2I is not acceptable. Why? Because MATLAB thinks of 2I as a complex number, and that would be in the denominator. That means the entire 2I is in the denominator, which is not the case here. I is in numerator, right? So if you put 3 divided by 2 times I, then 3 divided by 2 would be done first, and then times I, which is correct. Or 3I divided by 2, that's also correct. But 3 divided by 2I would not be acceptable because the 2I would be thought of as a denominator, right? The 2I itself is a quantity, right? It's a complex number, and that's the denominator, and that's not the case here. So you can erase that one. Yep. And last one. Again, this case, we want the 2I to be in the denominator. So we would do it the simple way, which is very good. And that would do the job. So now, as I said, it's not just about writing something correctly, it's also making it with the least amount of complexities involved in the way you present it. The simplest way means easier to debug, less memory usage to store it as a machine code, and you know what's going on because it's simpler in the presentation. Anybody wants to ask David something? And of course, you can execute it and see that the results will be the same, whether you use your lines or these lines. But at least these lines will be simpler, right? It's 4 lines only. That's it. The whole thing is 4 lines. And if you see 0.0000 as a real part, that means it's a real number. That's all it means, right? Or it's an it's a pure imaginary number. Ask David. I think David, somebody had a chat question. Or if the file does not exist, you can go to new or new, and then from the little black triangle you decide whether it's a new script or a new script that would be straight up, or you can decide with the script a function. Later on we will learn about these things, right? But if the file already exists, then when you double click on the file itself, in this case, which file would that be? Yes, not class project, homework one or whatever, right? Yes, the first one, that's the M file, right? Not the one related to some additional information that could be available, but which we don't look at, right? But in this case, that's the M file that we go to, and when you double click, it opens the editor right away, right? For execution, for debugging, for whatever reason you want to do that, right? Third one, so again, in that case, you have a system where they would like to figure out an experiment where they want to perform an experiment in a container over constant pressure, right? Constant pressure. And so that means whatever they do to things, the pressure is maintained constant. And since we see that the pressure is proportional to the temperature in degrees Kelvin and inversely proportional to the volume of the gas, the others being just constants, right? So that means if we vary the temperature, the volume has to vary so that the ratio is still a constant, since we say constant pressure. So what they're telling you here is that we have already conducted the experiment where we saw for a given temperature, the volume was something, right? Had some value. Theoretically, you could say that, yeah, but if I know N and R, then I can find out what the pressure is. Then I can use the pressure for the second case to find the unknown, meaning for a different temperature, then I will know what the volume is, and so on and so forth. But whenever you have these expressions with constants involved, and you don't want to evaluate unnecessarily things that may be useful but not needed. And I'll give you an example here. Momentarily, I hope, David, you'll forgive me, but I will come back to you, don't worry. Right? I just want to share the camera here. So in this case, the expression that is given is P equal NR T over V. So what it means is that if I conduct the experiment once or twice, the first one is NR T1 over V1. And the second time I conduct the experiment, P2 equal NR T2 over V2. But we know that because we said constant pressure, that means P1 is equal to P2. So what it means here is that NR T1 over V1 over NR T2 over V2 has to be equal to 1, because P1 over P2 is 1. They're equal. So therefore, the N and R can cancel. And so what I have is V1 over T1 equal V2 over T2. And so now the question is, they said, find the volume for the second temperature. So let's say volume 2, therefore, is equal to 2 over T1 times V1. So if I do little manipulation like this, then MATLAB doesn't have to do anything else. That's a single instruction line, kind of, right? A single one. Of course, you can always provide the data separately, which is good, right? But at least it doesn't involve calculations unnecessary, because if you calculate P1 then you use P1 being equal to P2 then to evaluate V2. That's additional calculations. And the more steps you take, the more mistakes you may have in the way you write the instructions. So here it's a simple thing. So you can always say, no, let MATLAB do the calculations. I don't want to do any calculations or manipulation of expressions. But sometimes you may have to, right? Evaluate something in between, which then you use to evaluate something else and so on, right? In that case, let MATLAB do it. For example, how do I find T2 in degrees Kelvin? I have to add 273.2 to the centigrade, right? Don't do it yourselves. Let MATLAB do it. So in this case, for example, I will write that V2 equal, and let's say in the data, right? In the data, I could do it two ways. I could write the degrees centigrade first and then make it Kelvin in the expression, or the way I present the data, I will also introduce the degrees Kelvin right away. So for example, T1 equal, and in this case it's minus negative 15 degrees centigrade. So I could say negative 15 plus 273.2. And then that would be my first one. And then T2 equal, what they say here, 31 degrees. So 31 plus 273.2. Then V1 equal 28,500. And then you provide a line for this expression. Of course, this will not be enough because, as I told you before, once you have a problem and you have questions like these, then I need sentences, I need units, I need whatever, right? So now I go back to David, and you can share your screen again, hopefully. Go ahead, David. Very good. So again, the P, as you see here, I didn't need it, right? I did not need that value. So, and I did not need N, and I did not need R. So what I would say is that, leave the stuff that you have. I don't want to erase it. So just go to the bottom and let's write the instructions as they are here. So we're going to say that T1 equal negative 15 plus 273.2. Negative 15 plus 273.2. Semicolon, because we don't want those displayed, right? We only want the final sentence. T2, the same thing, but it's 31 degrees. Semicolon. And then V1 equal 28,500. And that's very nice for you, of you to write it in one single line, because now the whole thing becomes only two things, right? Two lines. And then the next line, V2 equal percent moles. What do you mean percent moles? What does moles have to do with anything here? Oh, in his case, what he wrote, I don't know. Oh, yeah, well, that's the units, right? That's the units. Okay, V2 equal T2 over T1 times V1. Now the percent, it means it's a comment, because you cannot write units in MATLAB, right? I mean, you can have them in sentences, but not in calculations. V2 equal T2 over T1 times V1 times V1. And again, semicolon. Now write me a sentence, David. How would you write the sentence for it? You cannot write it that way, right? You have to have disp at the beginning. Parentheses and bracket, because it's a piece, it's by pieces, right? You're gonna write it in pieces, so you need a bracket before the apostrophe. Yes. So the volume of the gas at, now we close the parentheses, the apostrophe, comma, and now I want it to be displayed at T2, right? So at, and then we say num to str. Now, because you have, remember, you cannot use values with the characters, right? So we have to use the converter, right? Yes. And then we add the units, right? So here again, comma, apostrophe, space, and what's the unit here for T2? Degrees Kelvin. Close the apostrophe. No, sorry. No, is the volume of the gas at is space apostrophe, again comma, and then num to str v2, and then the units. And whatever the volume, which is cubic feet. Bracket. And before you do anything, ask them first if they have any problems with the way you wrote things. Did you have anybody asking you anything? I myself don't even understand the question. What do you mean, what are other commands? What do you mean, what are other commands? Shafiq? I'm sorry. Anybody real about 82, 83, 84? So anytime you have a percent, it means that's a comment that's for you to know what that means, and but it's not, it doesn't get executed, right? It's for you to remember what R stood for. Maybe he could have said R is the constant of whatever, you know, and so on and so forth, right? I know it's hard, right? Especially when David is not using his microphone. But let me try to say. First, you use the command called
Can you hear
display.
me?
Oh, yeah.
Okay.
Go ahead.
Last week it wasn't working, so I assumed it wouldn't work this week as well. But
It
it's good
works
that you
fine.
guys can hear my voice.
Go ahead, man. You're up.
Wait, so you want me to explain line 84?
Yes, of
Okay.
course.
So we use the disp command that basically displays whatever text or whatever you put in the parentheses in the command window when you run it. And then we had to add brackets because that allows you to put in multiple like strings or numbers and
No,
paste
no,
them
not
together.
numbers. It's still, even those numbers are strings
Yeah.
because it's the ASCII code that's used. Yes, yes, yes.
Okay.
So you say multiple pieces.
Yeah. So inside that we put the volume of the gas at inside of parentheses. So that's, I mean, not parentheses, uh, sorry,
Apostrophe.
apostrophes. And then there's a space afterwards so that it doesn't just put together all of this into one lump. And then there's a comma to separate that from the next command, which is num to
Not command.
str.
Next piece. Next piece.
The next piece.
Next
Okay.
piece.
Sorry, I don't
Yeah.
know the terminology. Um,
That's all right.
the apostrophe displays too. No, the apostrophe just shows the computer that it's a string.
Where the string is located, yes.
Um, okay, so then the next piece is num to str. So this takes whatever the variable you put inside the parentheses and
Oh, the value. The
of
value.
the value and turns it into a string. So it will display the value of t2 as a string in between these two
And using what?
strings.
Using what? What is it? What we said we use in what?
ASCII code.
How does it turn it into a string?
It takes the value and then it relates that to uh, a character on the ASCII code, right?
Very good. It records it through the ASCII code. Very good.
And then there's another comma and then another string, which has space, degrees Kelvin is, and then another space, and then we did that again for the volume, and then after that we put cubic feet to show what the uh, to show what the unit is, and then end bracket and parentheses.
Now the brackets you haven't seen it yet in the future, but it's usually to tell MATLAB this is a bunch of things, a bunch of numbers, a bunch of characters, whatever it is that you provide in pieces, right? A bunch of, you need those brackets. The parentheses, they're needed because every function you use, you have to use parentheses, right? However, I just wanted to mention something a little bit maybe not expected. If I have the value 12, but written inside the string, let's say the volume of the gas number 55, but all in between apostrophes, right? The 55, you don't have to worry about it. It's already converted to ASCII code by MATLAB. You don't have to use num to str, as long as it's in between apostrophes, right? But here I have T2, I mean, not T2, T2 or V2, it doesn't matter. Uh, it's a variable, but it's not a number that I know ahead of time. Until MATLAB calculates it, I don't know. If I knew it, I would just put it in between apostrophes. If it's like, say, 22, I'd put 22 in between apostrophes, that's good enough. But because I don't know and I have to use the variable, which is given in numbers, in values, not ASCII code, that's why we use num to str for anything you don't know yet. If you know it, then you just put it straight in between apostrophes. And that simplifies the problem. T2 is the temperature, right? That's the T2, the temperature at which the volume is not known, right? We know at T1 what happens to V1, but at T2 we don't know what happens at V2 to V2. So, and you run it, and then what do you get? I suppose you get the same number, right? Why is it that we don't get the same value? Any reason?
I converted all the units to SI units when I ran it.
I know, but V2 is supposed to be in cubic feet. Oh, no, you did what? In cubic meter? Cubic meter?
Yeah.
Okay, that's fine with me, but then the problem is that you don't have the unit, so we don't know if it's correct or not, right? But if you said cubic meter, then it would have been maybe correct. So, meaning it would have been accepted, right? As long as the units are there. So that's why I told you before how important the units are. And of course, the sentence would have been a necessity. Every time there is a problem now with questions, and the answers have to appear in sentences. The first two, it was just manipulation of numbers. You don't need sentences. But in the case of the third problem, the sentence is necessary. So in the future, I don't have to remind you. It has to be there. Oh yeah, you wrote cubic meters as a comment, but I wanted it to appear in the sentence, right? As part of the result. Because the comments don't appear in the results, right? They appear in the source code, but not in the results. So how would I know V2 is 950 cubic meters?
Yeah, I wasn't sure what you wanted there. So sorry about that.
It's all right. And I'm trying to figure out even if that number is correct. Because a cubic meter,
Yeah.
oh, that's 27, right? 27. 27,950, that doesn't make 33,000, right? Oh, no, it's more than 3. Sorry, my bad. It takes more than 3 feet to make a meter, right? So my bad. Sorry, I don't know. I don't want to say anything else. So the only thing I would say is that, you know, if you had a sentence with the cubic meters, that would have been absolutely acceptable. Ask them if they have anything else to say.
You guys have anything else to say?
I think they're mesmerized by your abilities. And Shafik agrees. Okay, thank you, David. Let's go to the lecture if you have nothing to ask, obviously, at this point, right? So we'll just go and lecture again, right, and learn new things. And again, remember this. Uh-oh, now the guy's gone. Well, he can still answer your question, obviously. Unfortunately, you don't have access to his. Okay, so how when you say comment turn red, we don't know what that means. Are you sure it's a comment? Because red, that means there is an error somewhere, right? Oh, pound sign instead of percent. Yes. Very good. So, hey, that's what I love about, you know, you doing it, right? You debug your own things. You teach yourselves, you know. You talk to each other. So when you ask a question, you force somebody to learn, because to answer the question, they may have to come up with something they haven't thought of. Yes, definitely. Okie dokie. Okay, so I forget where we stopped the last time. I think. Oh yes, we dealt with a complex number. So we're gonna go straight to the display formats, which we already talked about. Don't worry, it's being recorded, so we'll start without you. But please do come back. So in this case, let me first, go to the PowerPoint. All right. So the next topic here is about format. We already discussed the format short, format long, 4 digits after the decimal point, 15 digits after the decimal point. And we have the same situation for the engineering or scientific display or whatever other type of labeling, right? In this case, that we display either very small numbers or very large numbers, right? And when we have very small numbers or very large numbers, then the direct format would not be acceptable, especially when you have high powers of 10 or very small numbers in negative powers of 10, right? So in that case, we have a number that is displayed as two parts. This is, the mantissa and the e exponent. That means to the power 3 in this case, right? So we have the exponent and the mantissa. The mantissa is going to be somewhere between 1 and 9.99999, some number below 10, right? That's the format that is chosen. It doesn't matter how large the number is or how small. This mantissa has to be between 1 and 9.999 and so on. And the rest is a power of 10. So if you want the mantissa to have only 4 digits of the decimal display, then you say format short E, right? For engineering display, right? Engineering notation, that is. And if you want more digits available to the mantissa, then the format long E would do the job. And the rest is E means 10 to the power, right? And you yourselves also can present numbers that way. That means instead of writing 1,000, you can say 1E3. Instead of saying 200,000, you can say 2E5. 2 times 10 to the power 5. That's the same thing. So 2E5, especially if you have 200 million, you don't want to write 2 and then 8 zeros, right? So you just write 2E8, and that would do the job. Right? So you can also use that format to input values, right? And of course, MATLAB will automatically display based on whatever it judges useful. So sometimes, especially when you have small numbers and large numbers at the same time, it may turn into this engine format automatically. Of course, there will be formats that you can control, that you decide how many digits, how the result should be displayed, and so on. But if we use the default, that would be format short, format long, format short E, format long E, meaning that we can control it, but still it's under these two possible formats, right? Whether it's 4 digits after decimal point or 15, but it's still at least partially under your control. Now, arrays. When we deal with a bunch of numbers, just like you had an example of that when you did the display, and you had the sentence made of pieces, right? A bunch of pieces. So when you have a bunch of anything, then we call that an array. An array of numbers, an array of characters, an array of substrings, you name it, right? So in this case, when the numbers are listed together in one row, that's called a row vector. So even though it's a bunch of numbers, but we call it vector if it's only a single row. If it's a single column, we also call that a vector, right? But it's a column vector. So even though they are arrays, but we use the word vector when it's a single row or a single column. When you have multiple rows and multiple columns, right? Okay, yeah, I'm supposed to control the right side, and I wonder why it doesn't move, right? When you have a bunch of rows and a bunch of columns, then you have to use the word array. Right? And of course, later on, you will see also a term that sometimes we mix together, which is the word matrix. So an array, a matrix are the same thing. They represent the same thing. But again, when it's a row or a vector, a column, we call that a single column or single row, we call them vectors, right? So the word array or matrix are interchangeable, except as far as MATLAB is concerned, when you start performing operations, whether you perform matrix operations or what we call later element by element operations, and that's something we will do this semester a lot of, right? We will do some matrix manipulation, but most of our calculations are about element by element. So in this case, you cannot use under element by element the word matrix, right? Because matrix for MATLAB, it means a specific set of conditions, and the way the operations take place are different, right, from the element by element. So except for one case that we will use, as far as we're concerned, it's always element by element operations, and therefore we will use the word arrays rather than matrices. So as an example also where these arrays are useful. For example, when we plot a graph, right? When we plot a graph, the way we do it is that we take points on a graph, x, y, x, y, x, y, x, y, and then we connect them together. And that's exactly what MATLAB does. In fact, in terms of plotting, it takes one point and the next point, the consecutive, right, and puts a straight line in between. To you, it looks like a smooth curve, right? And that's because we have so many points, and usually we do that, right, on purpose. We take so many points that in between, if it's straight line, but if they're narrow enough or short enough, then it looks like a smooth curve variation. So at some point when you do a graph, you have to make sure you have enough points. If you don't have enough points, then you will see that zigzag type of connection between two consecutive points. And it may not look exactly like the curve you want, like, for example, an exponential or a logarithm or a sine wave or whatever, right? So you have to have enough points so that it looks like a smooth variation where two consecutive points are connected through a single line. So to generate the points, then we generate them through an array. And the array, the way we present it, I mean, if I have 1,000 points, I'm not going to say 0, 0.001, 0.002, 0.003. I'm not going to write them down. There'll be 1,000 numbers. Imagine 10,000, 100,000. You can't do that. So MATLAB has provided us with a way when two consecutive points, they're all separated by the same amount, right? By the same increment. So they're separated by the same amount, right? Like 0.1, 0.2, 0.3. It's always 0.1 in between, right? Therefore, we provide them through this arrangement. The first number is the minimum of the list. The second number is the increment. That means what is it that you add to the previous number to get the next number. And the last one is the maximum value available in that list. However, we'll discuss exactly whether that maximum is part of the list or not. But what it means is that you just take the first value, a min, add to it the increment, like in this case, add 0. If I add 0.5, that becomes 0.5. If I add 0.5 to this one, it becomes 1. If I add 0.5, it becomes 1.5. If I add 0.5, so you just add the increment until you reach the last value, and that's where you stop. So this here is generated by this single instruction. However, in the next case, I wanted to show that if you have 1 plus 3 is 4, plus 3 is 7, plus 3 is 10, plus 3 is 13, plus 3 is 16. If I go plus 3, it becomes 19. Hey, 19 is greater than 17, therefore it cannot be part of the list. But you see here, 17 is not part of the list. So that maximum value is not necessarily part of the list. But that means you cannot exceed it, because after 16, it's 19, and you exceed 17, therefore that's it, you stop. So this is an example just to show you that that maximum is not necessarily part of the list. It just gives you a threshold that you cannot exceed. And in a particular case where the increment is 1, then you don't have to put it. You see here, instead of saying 0, 1, 10, you just skip it. And if you skip the 1, the default is +1, +1, +1, +1. And as you see in between, we use columns, right? Not semicolons, not commas, but columns. Anybody wants to ask anything so far? Nope. Okie dokie. So another consequence of dealing with arrays. For example, U is an array because we have seen it, right? 0.51, 1.52, and so on, right? A bunch of numbers. Then we define a new variable which depends on U. U is an array. Therefore, W also is an array, meaning that MATLAB will evaluate W for every value of U. U equals 0, it will find W. For U equals 0.5, it will find W. So W itself is going to be an array of numbers with as many numbers as U, right? For every value of U, W will be evaluated. So you don't have to say W is an array because W depends on an array, so itself it will be an array. That means it will evaluate W for every value of U, which is good for us, right? When we want to find how a function behaves, we'll say for every value X, find Y, and then plot them, right? So, and also a way to point, like somebody says, can you tell me what the fourth element of that array is? What the ninth element is? What the 50th element is? And so on, right? It's like, imagine the students have taken quizzes and I want to know what the quiz grade for the 7th student. So how do I tell MATLAB for the 7th student I need to know what the quiz is? So by using U4, that means give me the fourth element of the array U. And so if you look at U, you have 0, 0.5, 1, 1.5. So 1.5 happens to be the fourth element, right? Fourth element. If you see it here, 0, 0.5, 1, 1.5. So first element, second element, third element, fourth element. And so the fourth element would be 1.5. And of course, if I want the fifth element, U of 5, that'll be 2, right? That's the next one. And of course, in many cases, when you write a program, you want to point to, let's say, what's the salary of the fifth employee, right? What's the price of the second merchandise or something, right? Now, if you look at this array, you have 0, 4, and it's like the kind of problems that you have seen before regarding the fence and a post, right? So when somebody says, I have built a fence, and there are 10 intervals, each one 1 yard long, 1 meter long, whatever, right? But then the question is, how many posts are there? So I have a fence with 10 intervals. How many posts do you think I have to put together to build that fence? Anybody? A fence which has 10 intervals. How many posts do I need to put it together? Well, I'll give you a simpler number. I have 2 intervals in a fence. 11, yes, because there is a need for a post at the beginning and a need a post at the end, right? So here it's similar in a sense that when you look at the number of elements, 0.5 here, you see that there are 4 minus 0 divided by 0.5, which is 8 plus 1. That means the number of intervals may be 8, but the number of elements is 9. There's always that plus 1, right? So if you see here the number of intervals, 1 interval, 2 intervals, 3, 4, 5, 6, 7, 8. But the number of elements is 8 plus 1. So the number of elements in an array, which is built this way, right, is A max minus A min over increment plus 1. And of course, it's the integer portion of that result that matters, right? If it's not an integer. And so this is how you figure out, like if I say 0 to 1,000 and 0.1 as an increment, how many values, how many elements does that array have? From 0 to 1,000, every 0.1. How many elements do I have? Be careful. Be careful. I said from 0 to 1,000, but 0.1 increment, 0.1. So revise the last number, Shafiq. What you gave me is every 1. I said every 0.1. So it'll be 1,000 minus 0 divided by 0.1 plus 1. What do you think that gives you? 1,000 over 0.1, what would that be? The other way. Yes. And now you add 1, and you tell me what the final result is. Yes. Because 1,000 divided by 0.1 is like 10 times 1,000, right? When you divide by 0.1, it's the same thing as multiplying by 10, right? Because multiply the numerator and the denominator by 10, it'll be 10,000 over 1, right? So, yes. So I'm just saying that, you know, one has to be aware of how the number of elements are affected. But that plus 1, when you have a 10,000 numbers, who cares, right? But still, you never know how. I mean, if I have 10,001 employees, it's not the same thing as 10,000 employees, right? It's not the same thing. So one has to be careful, right? Because then 10,001, you have to prepare 10,001 files to give to the government, to the IRS, to the insurance company, whatever it is, right? So you have to be very aware of that. Now, another way where if you don't want to evaluate, I mean, sometimes I have a an array given to me by somebody. I'm not going to go to the data and try to figure out how many employees that company has. So if I ask MATLAB length of view, automatically it's going to give me 9 in this case, or whatever, yeah, 9. It will know. It will let you know. So I don't have to do it by hand, right? And of course, when it's 9, it's not a big deal. But if it's 10,000, I'm not going to go and 1, 2, 3, 4. Well, no, I'm going to ask MATLAB. And the way to ask MATLAB is through the instruction called length. So when I ask for the length of a given variable, which is an array in this case, it will respond by saying the length is 9. Right? Of course, it will just say 9, right? Answer equal 9. We'll just keep going with the lecture, right? I mean, I could go through examples, but let's go with the lecture, and then we come back, and then we look at the different things that we have seen, and then we practice with more problems from the book, right? So we will have examples first, then problems from the book, and then, of course, at the end, I will ask you, please solve this and submit. Practice without it, you can never learn, right? So another part that is very important to engineers, scientists, and everybody else who has to deal with the mathematical model. It doesn't matter what your function is, right? And as I said before, in life, almost everything is described by a mathematical model. One of the expressions that is most popular in modeling is polynomial. A polynomial is a bunch of terms. Let's say if the variable is x, it could be a constant, and different powers of x and weighted version of it. That means some constant times x cubed, some constant times x4, and you add them together. That's what we call a polynomial. For example, this here is a fifth degree polynomial. It doesn't matter how many terms it has, but if the highest power is 5, we'll call it a fifth degree polynomial. Now, how do I tell MATLAB it's a polynomial? And what kind of polynomial it is? By giving the coefficients of the polynomial. So here, the application was find the zeros of this polynomial. So, but until I know how to do it, I have to tell MATLAB it's a polynomial. So the way to do it is to present to this array. You take the coefficients and you give them to MATLAB. However, you don't give the coefficients as 1, -7, +40, -34, because how does MATLAB know there is a term missing, that it is a fifth degree polynomial? That means you have to give every coefficient, meaning the coefficient of the highest degree term is 1. But the coefficient of x4, because x4 is not there, that means it's 0. They have to tell MATLAB it's 0. Their x cubed is -7, x squared is +40, but there is no x. So I have to tell MATLAB that the coefficient of x is 0, and then the constant -34. So here I give all the coefficients, and because it's 6 coefficients, MATLAB knows it's a fifth degree polynomial. Right? MATLAB will know, right? Because you gave every possible coefficient up to the highest degree term. It will know it's a fifth degree polynomial. So do not skip the 0 terms when they exist, meaning if a power of x is not there, it means its coefficient is 0, you have to include it. And once you include every possible coefficient, there is no ambiguity. MATLAB will know it's a fifth degree polynomial, and that's this polynomial specifically. Okay? So, as an example, when I say to MATLAB, this is my polynomial, meaning that these are the coefficients of my polynomial, I didn't put a semicolon here, so it will come back and will show me what that array looks like. And this is why I told you about CLC, clear the command window. Imagine if by mistake, instead of P, you displayed an array with 10,001 numbers. That'd be a disaster. Imagine if you have 100 numbers per screen, that's 100 windows. And then to climb up to the top, you have to scroll through 100 windows. So that's why CLC would have been a good idea, just in case it happens by mistake, right? But this here is just to say, this is my polynomial. And polynomial means just give me the coefficients. However, then there is a function created by MathWorks which looks for and finds the roots of the polynomial. The roots, I go back here, it means when the polynomial equals 0. So that's what we call the roots. The roots, that means the values of x that will make the polynomial equal to 0. And many times, I need to know when it crosses 0. We will see maybe a few applications why we are interested, but there are so many fields where that 0 crossing is important. So in this case, if I were interested in this equation, you know, of course, in your case, you have done a lot with quadratic equation, right? Ax squared plus bx plus c equals 0. That's what we call the quadratic equation. So you want to know what values of x will make the polynomial equal to 0. And so in this case, the function that they created was called roots. And as an input, you give me the coefficients of the polynomial. So once you go to MATLAB and ask for roots to be executed, and you give it the coefficients of the polynomial, then you have the roots here. And obviously, 5th degree, 5 roots. 10th degree, 10 roots. 20th degree, 20 roots, and so on. However, now it's something you may learn in math class, or something you learned from MATLAB. Because sometimes when I try MATLAB in different situations, I get to learn something from it. That means the behavior, I can find a pattern in the behavior. For example, one of the patterns that you will find is that if the polynomial has real coefficients, you see 1, 0, -7, and so on, are real numbers, not complex, they're real. If the polynomial has real coefficients, then one of the consequences is that if one root is complex, the complex conjugate of it is also a root. You see these two complex numbers? Same real part, but the imaginary part is plus and negative. That's what we call complex conjugate, right? So if a root is complex, then the complex conjugate has to be a root. So I'll ask you this question. What's the maximum number So I'm not talking about this fifth degree polynomial, but any fifth degree polynomial. What is the maximum number of complex roots it can have? You can answer, but also be careful about the answer, and then you explain why you answered that way. A fifth degree polynomial, what's the maximum number of complex roots it can have? And can you please explain, David? And you can use the microphone, it's nice. You have a good microphone, so let's enjoy it.
If each complex number has to come along with its conjugate, then that means that the number of complex roots has to be even.
Very good. Or the counterexample, if it can have 5 complex roots, where is the complex conjugate of the fifth one? It cannot be there because 5 is the maximum, right? So it cannot have 5 complex roots. But your explanation is absolutely perfect. Since if we're dealing with polynomials with the real coefficients, the number of complex roots has to be even. It's either 2 or 4 or 6 or 8, but it cannot be odd because the complex and the complex conjugate have to be roots. So it has to be even. Very good. It's an even number of complex roots. So it can have 0, 2, or 4 complex roots. That's it. There's no other possibility. You all agree? And of course, you could have seen it even if you did not know. You try it again with different polynomials of fifth degree, of course, and you will see that either all real, 2 complex, or 4 complex. And that's it. You will never have anything in between. Then you may decide, hey, of course, you could always show it, prove it, right, with specific cases, right? That if we apply those roots to that polynomial to end up with real coefficients, that complex conjugate has to be there. It's a must. But you can always also look at it from whatever experiments, examples you take. Of course, examples, it's not the same thing as a theory, because just because you did it 10 times, 100 times, 1,000 times, it doesn't mean it's true for every possible case. But in this case, it is true. At least you can believe me. So good thinking, good conclusion. Yes, roots, in this case, zeros. Yes, same thing. Zeros, roots, the same thing, right? Because it's kind of a numerator of a ratio. The ratio here, denominator is 1. So, but when we have a ratio, just in case, right? When we have a ratio, what does MHM means? Maybe you young guys know, but I don't. MHM, what does that mean? No,
No,
OMG,
no.
that's oh my God.
Yeah, I was like, like
Huh? Oh, I know. I've seen the ha 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 ha. That I know, right? It's easy to know what it means, right? But uh, yes, what was I gonna say? Um, oh, yes, yes, yes. So as I said, when you have just a polynomial equals zero, we call that roots, but also called zeros, right? But the word zeros really became useful when we had the ratio of polynomials, numerator over denominator. The roots of the numerator, we call them zeros, and the roots of the denominator, we call them poles, right? Zeros and poles. Even though in this specific case, polynomial equals zero, you can also call them zeros, right? You don't have to call them roots. Roots is like a general term. Whether it's a numerator or denominator, anything that makes something zero is called the root. But for a specific ratio, we talk about zeros for the numerator and poles for the denominator. But all of them are called roots. So anything that makes something zero is a root, right? But zeros mostly when we deal with the numerator, which in this case, a polynomial is like same thing, polynomial over 1, right? So you could think of it as a numerator. Now, additional functions. We have functions called square root, right? Of course, you can think of it as to the power 1/2. That's the same thing. But sometimes, it's a bit awkward to try to write the power 1/2, and we will see later why in terms of the parentheses or how MATLAB will look at the 1/2 and so on, right? But they decide, okay, square root is available to you. Exponential. Now here I have to be careful because I know no matter what I say, there will always be a student or two that when they write the MATLAB thing, they will write e to the power x. It does not work, right? E to the power x is not accepted by MATLAB. You remember the e that we used? E3 means 10 to the power 3, right? But e to the power x does not exist. Well, you can say that e is 2.71 something, right? When we do the exponential of 1. Yeah, but then how do I know you wrote enough digits to make it accurate enough? So let MATLAB deal with it. And they created the function exp. That's how you provide the exponential. Exponential 3 is exp3, right? So the exp is the function that is accepted. Now for the logarithm, you have to be careful again. In math, the natural log is ln, and the log base 10 is log. Sometimes we don't even write 10. Small log means log base 10, right? By default. But in MATLAB, log is the natural log, and for log base 10, it's written explicitly log 10, right? So log base 10 is written explicitly, but natural log is log. And again, when you pick it up from a math expression, you see ln, and it's not ln that is available in MATLAB, and it's log, and log here, even though in math it may say log base 10, but here it means natural log. So again, those things you have to be aware of and accept, right? Because they programmed it that way, we just follow, right? We don't have a choice. Now, when you deal with trigonometric functions, whether it's sine, cosine, tangent, cotangent, you name it, right? The default, when it was created, and that's because when we dealt with sine waves, it's the type sine omega t, right? It depends on time domain. So omega is in radian per second, t is seconds, radian per second times second is radians. So that means it was assumed that the argument is in radians, the angle is in radians. And so the default when they started was sine, cosine, tangent, what have you, are all expecting x to be in radians. And again, remember, in math we write sine x, but in MATLAB we always have to have parentheses. A sine is a function, log base 10 is a function, SQRT is a function. Anytime you use a function, you have to have parentheses. So this would be sine x, this would be cosine x, and so on. Tangent x would be tan, and so on. However, we as users are more comfortable with some things. For example, when I deal with numbers, how many people do you know that are savvy with the binary system? Very, very few on this planet, that's for sure. Hexadecimal, the hell with that. I don't even know that if 99.9% know what it is. Oh, no, that's not true. Of course, I'm exaggerating because you have the engineers, the computer scientists, the computer engineers, and now more and more people, for that matter, that know that stuff. Just like you guys now know about the ASCII code and you name it, right? But then you're engineers, so it's normal that you should know these things, right? So in the case of the general public, when you say to somebody, how old are you? You don't expect that person to answer in hex or binary or whatever, right? It's in decimal. And when you give them a result, they expect it in decimal. So the same thing with angles. People have an easier time to dealing with degrees than dealing with radians. If I say 25 degrees, I have an idea of 25 degrees, what it means, what it is equal to. But if you tell me 0.2 radians, I don't know what that means, right? And my mind does not click right away. Yeah, when you tell me pi over 2, pi over 4, yes, I know that. But pi over 10, I don't know what that is equal to. Oh, yes, of course, pi over 10 means 180 divided by 10 is 18 degrees. 18 degrees, I can visualize what it looks like or how big it is and whatever. So I still think of 80 degrees, right? I mean 18 degrees. But if you say 0.2 radians, I don't even know what that means. I have to figure out how it relates to pi. Then I have to relate pi to 180 degrees before I can see what it means. So they said, okay, instead of you having to convert degrees to radians, and we're not talking about the simple conversion here. There are many other cases involved. That's why they created functions where they took the sine, cosine, tangent, and they just added the d to it. Of course, they added the d just to label those functions. But now the functions, sine d, for example, x is in degrees now. You can give x in degrees. Sine d, 45 degrees. Sine d, 90 degrees. Sine d, 125 degrees, whatever, right? Whereas if you put sine, then x has to be in radians. And that's important, right? I mean, you'll get used to it once you get, to use it. But, before that, all the students had to convert degrees to radians before they can use trigonometric functions. And of course, when you do the a sine, and again, in math, we use sine to the power minus 1. We use arc sine, but in MATLAB, it's a sine, a cosine, a tan, and so on, right? And it's the arc tangent, the arc sine, the arc cosine. And again, if I give a number, the result will be in radians. So now it's not given the angle in radians, because arc sine means tell me what the angle is that whose sine is this number, right? And we're going to see an example of that. So, and if you want the answer in degrees, then you use a sine d. So that's just an additional d. And that's valid for cosine, tangent, you name it, right? Okay, well, forget about that. Well, then we'll just look at examples. So what we're going to do is I'm going to go back to polynomials. I'm going to go back to these functions, and I will ask you to practice. Script file, we already did it. So obviously, all these, will be just simple stuff as far as we're concerned. These will be additional instructions on how to make the plot look better, look more efficient, or provide us more information, right? And we will see an example of that, and then we will start practicing with problems, and hopefully I should be able to assign some of them. So in this case, we're going to do so that next time I don't go over those problems. I'm going to go over one problem, maybe out of 3, or 2 problems out of 4, whatever, and then I say the other 2, do them yourselves, right? So that, but that means the first 2, for example, I go through them to show what the values are, but the sentences, you have to write them yourselves. All right, so let's take a break, and then we'll go back first to practicing with these things, the polynomial, root function, all these functions themselves. And or we'll do that through problems from the book, right? So either way. All right, any questions before we take a break? And to Shafiq, I will say, No questions. So let's meet in about 5-10 minutes. It's a language. Yes, it's a language. You see, before you could have thought of MATLAB. Oh, you talk about I don't know. I was going to say MATLAB became a language. Yes. Yes, Nicholas, yes. Yes, Nicholas. Oh, you're talking about MATLAB. Yes. Before, as I said, it used to be just a bunch of programs, right? A bunch of programs does not make it a language. It's just a bunch of programs. But then they said, if I have a bunch of programs that now I can use, so it's not like you found the temperature for this, you find the temperature for that, or the volume for this. That's a specific case. But some people wrote some functions which are pertinent to everybody else, like the sine function, right? Everybody uses sine. So now, instead of writing a program to obtain the sine of a given angle, I just call that program. And that call became part of the so-called language, an instruction set. So it's just a bunch of instructions. And a bunch of instructions, that means it became a language, a programming language, just like C, C++, and everything, right? Even every time it's mostly a call, right, to a program, but because when you put them all together, it looks like a program. So let me go back to the chatting and see what's happening here. You still have until midnight to do it, remember? I didn't say you have to do it now. You still have until midnight to submit it. In fact, I extended it until Saturday, right? Because right now, the only thing I care about is that you practice, right? You practice. I want you to be good, because the exams, you don't have a choice, right? If you don't practice, how are you going to do well in the exams? You may have the correct value because you copied it from a friend, but you'll be flunking the exams, right? So I don't care how good you are with the homework, as long as you practice your best or correct. You will still get a good grade, but the program is like it's going to be 10% at most. The exams is at least 70%. So if you don't practice your homework, you're going to mess up the exam. So I don't care, but as long as you do it. An easier one? You wish. What we meant by easier usually, right? We like to make it user-friendly. And with time, I guarantee you that everything is a lot more user-friendly than what we had, let's say, 40 years ago, right? I think I'm giving it up to Saturday midnight, right? Oh, no. You can cheat right now. You can cheat tomorrow. You can cheat after tomorrow. How can you get away for 40 years? It's like a thief. You can get away today. You can get away tomorrow. A whole year of stealing and nothing, and not getting caught. But the day you get caught, you pay for everything. So it's not worth it. So 40 years of misery because you got away with cheating. It's sad that you think it's smart, right? Or some people would think it's smart, right? No, struggling is what makes you powerful. So let's first stop struggling for the next 5-10 minutes, and then we'll come back and we'll struggle some more. Of course, anything that you don't practice is hard. Anything. Walking is hard if you don't practice it. Imagine if you don't walk for a year, and then you, like those athletes, right? And then every step is like a nightmare. And every time you practice something, it becomes like, trivial, no big deal, man. And anything that is you don't struggle for is not going to be getting any respect from you. We always respect things that give us hard time, especially when we overcome it. Huh, we feel like kings. See you in few.